Dear students, in this part I will discuss some important questions of trigonometric functions. So let us start with question number 1. Prove that sec 8 theta minus 1 upon sec 4 theta minus 1 is equal to tan 8 theta upon tan 2 theta. Student, let us consider the left hand side of this trigonometric function. Left hand side is sec 8 theta minus 1 upon sec 4 theta minus 1. Converting converting the numerator and denominator in the cos form. If you write, you can write sec as 1 upon cos minus 1 upon 1 divided by 1 upon cos 4 theta minus 1 upon 1. Now taking LCM in the numerator and denominator of this expression. In the numerator, the LCM is cos 8 theta, and on taking the LCM, we get 1 minus cos 8 theta upon, in the denominator, the LCM is cos 4 theta and 1 minus cos 4 theta. Now, this is equal to 1 minus cos 8 theta upon cos 8 theta and into this denominator we will take the reciprocal of this denominator and multiply, so into cos 4 theta upon 1 minus cos 4 theta. As you all know that cos A is equal to 1 minus 2 sin square A upon 2. From this we can find that 1 minus cos A is equal to 2 sin square A by 2. So using this formula 1 minus cos A is equal to 2 sin square A by 2, you can write 1 minus cos theta is equal to 2 sin square and half of 8 theta, that is 4 theta, upon cos 8 theta into cos 4 theta. Similarly, writing this expression using the formula 1 minus cos A is equal to 2 sin square A by 2. This 1 minus cos 4 theta is equal to 2 sin square half of 4 theta, that is 2 theta. This keeping this 2 here because we will require it. So 2 sin 4 theta into cos 4 theta and keeping one sin 4 theta separate upon cos 8 theta into 2 sin square 2 theta. Now 2 sin 4 theta cos 4 theta. You know sin 2a is equal to 2 sin a cos a. Sin 2a, using the formula sin 2a is equal to 2 sin a cos a, we can write this 2 sin 4 theta cos 4 theta is equal to sin 8 theta into sin 4 theta upon cos 8 theta into 2 sin square 2 theta. Now sine upon cos. This sine upon cos is equal to 10. So this is equal to tan 8 theta into this sine 4 theta, again using this formula, sine 2a is equal to 2 sine a cos a, or sine a is equal to 2 sine a by 2 cos a by 2. We have the half of this angle here. So half of 2a is a. So we can write this sine 4 theta is equal to 2 sine 2 theta cos theta, 2 theta. Upon 2 sine square 2 theta. This 2 and 2 is cancelled here, and sine 2 theta, sine square 2 theta, sine 2 theta times cancelled, and you are left with only tan 8 theta into cos 2 theta upon sine 2 theta, which is equal to tan 8 theta into cos upon sine is cot 2 theta, which is further equal to tan 8 theta, and cot theta is, you know, is equal to 1 upon tan theta. So you can write this is equal to tan 1 upon tan 2 theta, and which is the right hand side of the expression. Therefore you can say that LHS is equal to RHS, that is equal to tan 8 theta upon tan 2 theta. Hence the solution of the question is complete. Student, next question, question number 2, very interesting question. Prove that under root 3 cosec 20 degree minus sec 20 degree is equal to 4. You don't know the value of cosec 20, you don't know the value of sec 20, then how to solve this question? See the approach. Let us consider the left hand side, which is under root 3 cosec 20 degree minus sec 20 degree. Now first let us convert cosec into sine and sec into cos. So this is equal to root 3 upon cosec theta is 1 upon sine theta, sine 20 degree minus 1 upon cos 20 degree. Now what to do? You don't know the value of sine 20 or cos 20, so now let us take the LCM and see what happens next. Sine 20 degree into cos 20 degree, and sine 20 cancelled, you get root 3 cos 20 degree minus cos 20 cancelled minus sine 20 degree. Now anyhow to bring it in the form sin a minus b. So for this the step is that multiply by 2 and divide by 2, because you know root 3 by 2 and here you will be having 1 by 2. These values you know. So multiply by 2 and divide by 2. Upon sin 20 degree cos 20 degree. Now this under root 3 upon 2, students, you know that under root 3 upon 2 is equal to sin 60 degree. So this is equal to 2 into sin 60 degree cos 30 degree cos 20 degree minus, and this 1 by 2 is the value of 1 by 2 sin a cos b, we have cos 60, value of cos 60 degree into sin 20 degree, because 1 by 2 is the value of cos 60, bringing it in the form sin a cos b minus cos a sin b upon sin 20 degree cos 20 degree. Now you can see Now the numerator is in the form of sin A cos B minus cos A sin B, and you know sin A cos B minus cos A sin B is equal to sin A minus B. So this is equal to 2 into sine of 60 degree minus 20 degree upon sine 20 degree cos 20 degree. So this is equal to 2 sine 60 minus 20 40 degree upon sine 20 degree into cos 20 degree. Now this sine 40 you can write sine 2 into 20 degree upon sine 20 degree cos 20 degree. And students, you know sine 2a is equal to 2 sine A cos A. So I can write this is equal to 2 into 2 sine 20 degree cos 20 degree upon sine 20 degree cos 20 degree. Sine 20 degree sine 20 cancel cos 20 one time. 2 into 2 is equal to 4, and students, you have got the right hand side, you have got the required result. This is equal to right hand side, hence this question is complete. Next question, prove that cos square x plus cos square x plus pi upon 3 plus cos square x minus pi upon 3 is equal to 3 upon 2. So let us consider left hand side of this trigonometric function. Identity. Cos square x plus cos square x plus pi upon 3 plus cos square x minus pi upon 3. Right now we are not in a position to use any formula. So first let us bring it in the cos 2a form. So dividing by 2 and multiplying by 2. 1 upon 2 and 2 cos square x plus 2 cos square x plus pi upon 3 plus 2 cos square x minus pi upon 3. In the numerator multiply by 2, denominator balance it by 2 here. Now 2 cos square a, you know, 2 cos square a, you know, 2 cos square a is equal to 1 plus cos 2a. Cos 2a is equal to 2 cos square a minus 1, or 2 cos square a is equal to 1 plus cos 2a. So using this identity, you can write 2 cos square x is equal to 1 upon 2, 1 plus double of this angle, that is cos 2x, plus 1 plus cos of multiply by 2 here, 2x plus 2 pi upon 3, plus similarly here 2 cos square a is equal to 1 plus cos 2a, that is 1 plus cos 2 into x, 2x minus 2 pi upon 3 inside the angle multiplying by 2, because you know 2 cos square a is equal to 1 plus cos twice of the angle. Now 1, this 1 and 1 is 3, so I can write this is equal to 1, 3 plus cos 2x plus cos 2x plus 2 pi upon 3 plus cos 2x minus 2 pi upon 3, writing them together, cos 2x plus 2 pi upon 3 plus cos 2x minus 2 pi upon 3. Now I can apply c cos c plus cos d here. So this is equal to half into 3 plus cos 2x plus 2 cos sum of these two angles, then 2 pi upon 3, 2 upon pi upon 3 get cancelled, and 2x and 2x is 4x upon 2. Cos c minus d. Cos c minus d means 2x and 2x get cancelled. 2 pi upon 3 and 2 pi upon 3 will be added, divided by 2, that is 4 pi upon 3, and it will be divided by 2. So this is equal to half 3 plus cos 2x plus 2 cos 2x into cos 2, 2 times cancelled, cos 2 pi upon 3. Cos 2 pi upon 3 means cos 120 degree. Pi is 180, 2 into 180, that is 360, 120 degree, cos 120. Cos 2 pi upon 3 is equal to cos 60, 120 degree, and cos 120 degree is cos of 180 minus 60 degree, and in the second quadrant, first, because of 180, cos remains the cos, and this is equal to minus cos theta, that is minus cos 60 minus 1 by 2. So value of cos 2 pi upon 3 is minus 1 by 2. So you can write this is equal to half 3 plus cos 2x plus 2 cos 2x into this value is minus 1 by 2. This 2 and 2 is cancelled. So half of 3 plus cos 2x minus cos 2x is, and here cos 2x and cos 2x is cancelled. So you are left with 3 by 2, which is the right hand side, which was to be proved. Hence, the solution of the question is complete. 4. 180 divided by 12 is 15 degree. So 7.5 degree. Cos 7.5 degree is equal to root 2 plus root 3 plus root 4 plus under root 6. So I will consider here the left hand side. Cot of pi upon 24 means 7.5 degree, which is equal to cos 7.5 degree divided by sin 7.5 degree. Because you know cot theta is equal to cos theta upon sin theta. Now let us convert it into 15 degree, means bringing it in the form 2a. So for that, if you multiply by cos 7.5 degree here and divide by cos 7.5 degree, and to use the formula of 2 cos square a and 2 cos a sin a, multiply by 2 and balance it by 2 in the denominator. Now 2 cos square 7.5 degree is equal to 1 plus cos twice of 7.5, that is 15 degree, upon 2 cos sin 7.5 cos 2 sin a cos a, that is sin 15 degree, and I have used the identity that 2 cos square a is equal to 1 plus cos 2a, and 2 sin a cos a is equal to sin 2a. Now we can calculate the values of cos 15 degree and sin 15 degree. Cos 15 can be written as 1 plus cos of 45 degree minus 30 degree, and sin 15 degree is equal to sin of 45 degree minus 30 degree. Now to simplify this, let us use the formula cos A minus B is equal to cos A cos B plus sin A sin B. This is equal to 1 plus cos 45 degree into cos 30 degree plus sine 45 degree into sine 30 degree upon sine, using the formula of sine A minus B, sine A cos B, sine 45 degree cos 30 degree minus cos 45 degree sine 30 degree. Now putting the values, 1 plus value of cos 45 is 1 upon under root 2, value of cos 30 is root 3 upon 2, plus value of sine 45 is 1 upon root 2 and value of sine 30 is 1 upon 2. Similarly, in the denominator, sine 45 is equal to 1 upon root 2. Cos 30 is root 3 upon 2 plus minus cos 45 is 1 upon root 2 into sine 30 is 1 upon 2. Now taking LCM in the numerator and denominator, if you take LCM in the numerator, it is 2 root 2. LCM is 2 under root 2 and we have 2 root 2 plus under root 3 plus 1 upon, in the denominator LCM is again 2 root 2 and root 3 minus 1. On further simplification, this same value in the denominator, this is cancelled and you are left with 2 root 2 plus under root 3 plus 1 upon root 3 minus 1. To further simplify it, let us rationalize the denominator. So if we rationalize the denominator, then 2 root 2 plus root 3 plus 1 upon, in the denominator, root 3 minus 1. To rationalize it, multiply by root 3 plus 1 and divide by root 3 plus 1, opposite of the denominator. Now let us multiply. 2 root 2 multiplied with root 3 is 2 under root 6. 2 under root 2 multiplied with 1 is 2 under root 2. Under root 3 multiplied with root 3 is 3. And under root 3 multiplied with 1 is under root 3 plus 1 multiplied with root 3 is root 3 and plus 1 divided by root a minus b, a plus b. It is in the form, denominator is in the form a minus b, a plus b. So this is equal to a square, that is root 3 square minus 1 square. Now this is equal to 2 under root 6 and this 2 root 3 plus 2 under root 2 plus 4 and divided by under root 3 square is 3 and minus 1 square is 1, 3 minus 1. Now this is equal to, in the numerator we can take 2 as common. So we are left with root 6 here, root 3, then root 2 and then 2 and divided by 2. 2 and 2 get cancelled. So this is equal to, if we arrange the terms, then first is root 2 and this 2 is the square root, then root 3 and this 2 is the square root of 4. So I can write square root of 4 plus square root of 6 and this we have proved here that the value of cot pi by 4 is equal to root 2 plus root 3 plus root 4 plus under root 6. So the question is complete. Students, a very interesting question and tricky one. Question number 5. Prove that tan alpha plus 2 tan 2 alpha plus 4 tan 4 alpha plus 8 cot 8 alpha is equal to cot alpha. Now in this question, uh, if we write this in the form that transposing all these values to the right hand side, I can write this in the cot alpha, then minus tan alpha, minus 2 tan 2 alpha, minus 4 tan 4 alpha is equal to 8 cot 8 alpha. Means these are equivalent. If I transpose the other terms tan alpha and tan 2 tan 2 alpha, 4 tan 4 alpha, means with cot alpha I need tan alpha with it. So transposing the rest of the term, if I prove this, then this is equivalent to this result. That is, we need to prove this. For proving getting this result, here we have this form, cot alpha minus tan alpha. So for that, you know this identity, cot theta minus tan theta is equal to, cot theta is cos upon sine and tan theta is sine upon cos. I have transposed these value tan alpha in the right hand side, because with cot alpha I need tan alpha, so that I can use this identity which I am going to prove now. The LCM is sin theta cos theta, and sin theta cancelled. Cos theta into cos theta is cos square theta, minus cos theta get cancelled, minus sin square theta. This is equal to cos square theta minus sin square theta, you know, is equal to cos 2 theta. And to bring this in the 2 theta form, I am multiplying the numerator by 2 and multiplying the denominator by 2. 2 sin theta cos theta. It is balanced here. So we get 2, and this 2 sin theta cos theta is equal to sin 2 theta, 2 cos 2 theta upon sin 2 theta, which is equal to 2 cot 2 theta. So to prove this result, I will use this identity, that cot minus tan is equal to 2 cot 2 theta. So let us consider this, write it again, cot alpha minus tan alpha minus 2 tan 2 alpha, then minus 4 tan 4 alpha. Now this cot alpha minus tan alpha, according to this formula, you can add 2 cot 2 alpha. This together equal to 2 cot 2 alpha minus 2 tan 2 alpha plus minus 4 tan 4 alpha. Again, taking 2 common. If I take 2 common, cot 2 alpha minus tan 2 alpha minus 4 tan 4 alpha. Again using this identity, that cot theta minus tan theta is equal to twice cot of 2 theta, and here the theta is 2 alpha. So this is equal to 2 into 2 cot twice of 2 alpha, that is 4 alpha, minus 4 tan 4 alpha. So this is equal to 4 cot 4 alpha minus 4 tan 4 alpha. Again 4 is common, and inside the bracket you are having cot 4 alpha minus tan 4 alpha. Again this has taken this form, cot theta minus tan theta, which is equal to 2 cot 2 theta. So that is 4 into 2 cot twice of this angle, that is 8 alpha. which is equal to 8 cot 8 alpha, and this was to be proved here. So with this question I end today's session, and for some more important questions on this topic I will solve in part number 13. Like and subscribe my channel for new videos. Thank you, students.